Okay. Uniform acceleration implies that x of t equals this, the usual thing. Also that v of t is v of 0 plus at, just from the definitions of velocity and acceleration, the velocity and acceleration functions. Combining these, for example, eliminating a between this equation and this equation leads to this equation. Eliminating t between this equation and this equation, you get this equation, just using simultaneous equations. But the notation is a little bit complicated, so in simpler form and in more intuitive sense, we're going to let delta x equal x of t minus x of 0. Now that's just how far the thing goes between whenever you start the clock and time t. Vi is going to equal v of 0, which means that we're going to agree that the clock starts at some initial velocity, okay? And our analysis ends when we reach velocity v sub f, which is our v of t, just replaces our v of t. So that really all we're interested in is motion on an interval, the interval between two events. At the first of the two events, we get our initial velocity and time is set to 0. At the second of the two events, we say our velocity is the final velocity on that interval, okay, on the interval between the two events. And our displacement, the change in our position, is just x of t minus x of 0. So delta x is our change in position during that interval. Okay, so in that case, we can write the same equations in this form. Delta x is vi plus vf over 2 times delta t. And all this is saying is that the average velocity is vi plus vf over 2, which it must be when the acceleration is uniform. And you can just argue this intuitively from the fact that if the acceleration is uniform, the graph of v versus t is a straight line. If the graph of v versus t is a straight line, then on any interval, any t interval, the average velocity will be the average of the initial and final. Okay. Delta x equals vi delta t plus 1/2 a delta t squared, very much like this equation. We just subtract the x naught from the x of t. And vi is your v naught, and so forth. So it's really very easily to see how this relates to this. Vf is vi plus a delta t. Why? Because Vf minus Vi is the change in velocity. If you divide that by delta t, you get the acceleration. Okay, you just rearrange this to say acceleration is Vf minus Vi over delta t, change in velocity divided by change in time. And that's got to be so because you have a uniform acceleration. Okay? And then Vf squared equals Vi squared plus 2a delta x, which is just this equation with given notation. Okay? Now, the nice thing about these equations is that if you know any three of these quantities, you can easily find the other two, because any combination of three of the 5 quantities occurs in at least one of the equations. And each equation has 4 of the quantities. So if you know 3 of them, you can put them into an equation that contains the 3 and solve for the 4th. That's all there is to it. Very, very simple. Okay, so it's a very simple set of equations to apply if you can identify your quantities. So let's do an easy problem using these equations. Okay? How long does it take to travel 20 meters starting at 2 meters per second, accelerating at 10 meters per second squared? Well, I say, okay, let's list our quantities. We have delta t, delta x, vi, vf, and a. Okay? Which quantities do we know? Well, we travel 20 meters. What's that? Is that our acceleration? No. Is that a velocity? No. That's a displacement. So that's our delta x. We've got it. It's 20 meters. Starting at 2 meters per second should be a no-brainer. That's our initial velocity on this interval. Okay, so we have initial velocity. Accelerating at 10 meters per second squared, well, it's clearly the acceleration. So we look for equations that have these three quantities. Now, pretty soon we develop an intuition for these equations. We've got to solve some problems before we can do that. Okay? So let's see. Delta x, that's in the first equation. VI is in the first equation. And now A isn't. So we can't use the first equation. We have 4 variables here, and we only know 2 of them. We don't know VF, we don't know delta T. Second equation, delta x, yeah, we know that. VI, we know that. Delta T, we don't know. But A, we do know. Okay? So we could solve this equation for delta T. Now, I don't recommend that you actually do that, because it's a quadratic equation, and until you solve some quadratic equations and think about what the solutions mean, you get 2 solutions and stuff. It's a little more complicated, although if you can do it, that's fine. But mathematically, just a few more steps in the solution. Okay? We have VF and delta T as unknowns here. So there are 2 unknowns here. All we know is VI and A. We can't use this equation. We go to the 4th equation, which is actually quadratic as well as this one, but maybe easier to deal with. So we're going to use this equation. So we're going to use VF squared equals VI squared plus 2A delta x. Now we know VI, we know A, and we know delta x. So we get VF squared right away. VF squared, very simple to solve, to substitute these. You got 2 meters per second quantity squared plus 2 times 10 meters per second squared times 20 meters. You can fill in all of this. So that VF squared equals 2 meters per second quantity squared plus, well, 20 times 20 is 400. And that's going to be meters times meters is meters squared. You got seconds squared here. Well, when you square the 2 meters per second, you get meters squared per second squared plus 400 meters squared per second squared. And that equals 404 meters squared per second squared. So that VF can be plus or minus the square root of 404 meters squared per second squared, which could be plus or minus 20.1, very close to 20.1 meters per second. Then you can find your delta T, because that's the only variable you don't know anymore. Now you got VF, you find delta T using whichever equation you prefer that includes delta T. All these equations except this one include a delta T, so you can take your pick because you know the other 4 variables. Okay, so the easiest equation to use is probably this one. So you know that VF equals VI plus A delta T. So delta T is VF minus VI over delta T. VF minus VI could be plus 20.1 meters per second minus 2 meters per second. That would be 18.1 meters per second. And it's not divided by delta T, it's divided by A. Okay, so this could equal 18.1 meters per second over 10, or 1.81 seconds. Or you have a negative result. Negative 20.1 meters per second minus 2 meters per second is negative 22.1 meters per second. That would give us 2.21 seconds. Negative. Okay? Now, some people think you can't have negative time. Well, time starts when you start the dang clock. Okay? If it's been accelerating at this rate, if it was accelerating at this rate for at least 2.21 seconds before you started the clock, then the final velocity could well be negative 20.1 meters per second. And I think I said that wrong. Let's see. No, that's right. That's right. It could end up at 2 meters per second, having started 2.21 seconds before t equals 0, and traveling 20 meters, accelerating at 10 meters per second squared. And you want to kind of try to visualize that. I'm not going to go into a lot of detail to explain it. I'm just pointing out that sometimes you have two solutions for the time because of the quadratic nature of this and the quadratic nature of this one, actually, since VF is squared. Okay, so that's one possibility. Okay, and again, the negative 2.21 seconds mean this is accelerating at 10 meters per second squared, but it starts at negative 20.1 meters per second. This is going to go backwards for a while. 10 meters per second squared acceleration will slow it down, and then it'll start speeding up, and a little later it will get to the 20 meter position, still accelerating at 10 meters per second squared. Okay, so there we have it. Do you understand? You should understand the process of identifying 3 of these 5 quantities and finding the equations that lead you to solutions. It can be a very mechanical process, but then you always want to think about your solution and see if it makes sense.